Hello and welcome everyone to my presentation called Simple Modern Java Microservices in the Cloud. If your reaction is bingo, you win. The prizes will be distributed later. No, just kidding. My name is Andrzej Grzesik, but before I get there, if you're sleepy, if anything happens, as in if you, I don't know, need to read Twitter, Facebook, whatever it is that you read during the day today, the TLDR version is, if you are doing microservices, if you have a lot of complexity in your business and whatever you're dealing with, try to make the job easier for yourself. Limit the number of moving things. This will, especially if you are going to work with this problem for a long period of time, it will make your lives easier. And having said that, my name is Andrzej, and I know that this audience is very capable of actually pronouncing and spelling my name and surname, which is not always the case. I work at Revolut. I have a Twitter, a blog, and an email. If you need the slides, drop me an email. I'll send you the slides. That's easy. And I'm also a Java champion, a Java 1 rockstar, involved in Polish Java user group, Geekon, and some other initiatives. Now, if you have any questions about the talk, you need to ask. Easy. But there are bonuses. I don't know how many, but I know that some of the questions that you ask me, and if I choose to do so, I can reward with either an invitation to a party, an umbrella, which protects from the sun as well, or a mug. Or a handshake, if that's what you prefer. If you have any questions about Revolut, excellent. There is a booth. We are happy to talk. Or let's talk about working at Revolut. How is it actually to work at Revolut as opposed to what do the people of the internet say working at Revolut is like? Happy to discuss it. I've spent there so far 2 years and 9 months. So far I'm having fun. That's a conversation for you as well. So, obviously we're hiring, and a very important disclaimer, my opinions are my own, which means I do not represent the views of my employer. Yay. But I also like dry jokes, and if you see a dry joke, you're more than welcome to drink. Because I need to drink, because otherwise my throat will run dry and I will not be able to speak. So, modern Java microservices in the cloud. The very first question that we have to ask ourselves is, what makes a service modern? How do we keep it being modern? In order to get our minds into a correct state of mind to consider this, let's think about a hypothetical situation. It's imagine your dream project. Imagine the dream project in which if you need to make a change, it's easy. If you need to fix something, there is nothing to fix because everything runs correctly. If you need to add something amazing, you can do it. Everything is well-defined, well-described, has tests, runs performant, and basically work in such environment is super pleasant. Can you, or can some of you at least imagine this? I hope so. I hope you're not as scarred as some other people in the room with lots of strange experience. Now, having said that, the question that we have to ask is, what is bloat? Obviously, I said I love dry jokes, but the question that we need to seriously consider is, what is making the opposite of this best possible project out there happen? Is it going to be the language? What is your favorite language? As in, if I ask people in here, I'm going to hear a multitude of opinions, and that's fine. Some of you are going to be very, probably rightly so, convinced that if I just use language called X, Y, Z, whatever, everything is going to be fine because only in that language and nothing else it is possible to write optimum code. Every other language is just wrong. Somebody will say Scala, somebody will say Ceylon, somebody will say Clojure, somebody will say something else. When it comes to choosing languages and projects, I propose to use a different litmus test. I call it 2 a.m. check. Imagine you've been having fun out, and you come home, and then there is a call that, hey, there is something mishappening in the production environment or around the production environment. Can you actually log in and have a look? Obviously, this is this very rare situation in which it happens, but the language should not stand in the way. Which means if you're writing extremely smart code with, let's say, lots of squiggly line operators, then if you're slightly snake following and you have to figure out what's happening in your software, it is going to be extremely hard to fix it. I don't like such situations. And this is why, in my personal opinion, Java actually kicks the body parts that it needs to. I also like Scala, but I like and I'm only capable to write very simple Scala, just because this makes the code explicit and it makes it very simple and easy to understand, which means it's very straightforward, which means it's easy to maintain and fix when needed. And also because I did mention I work for Revolut, the question is, what do we do in Revolut? In Revolut, we default to Java. So most of our services are written in Java. There is some Kotlin, there is a tiny amount of Scala as well, but if we are talking about backend code, the 99 or maybe 85+% of that is going to be in Java. Now, so language, not the necessary element for having your software modern. Is it the framework? Which framework should we use today so that our software stack can be called modern? I don't know what we are going to answer, but imagine you're watching a video of this talk 10 years from now, so maybe it's year 2032, and there hasn't been a global nuclear war, and we are still able as a civilization to actually write software instead of having to figure out where to get food. What is going to be the answer for that? Is it going to change? Is it going to be just like writing J2EE right now is, as in, come on, it's not what you do. What I'm trying to say here, it's probably not the framework using one or using a specific version of one or not using it in the first place that's going to make or break software being modern. So what about databases? I think you get the drift already where I'm getting there. 20 years ago, SQL all the way. Oracle service, Postgres service, MySQL service, whatever else you were using in servers and clusters. And then came the era of NoSQL, which was first NoSQL, as in don't do it. Then there was the era of NoSQL, as in not only SQL. And now we're back to SQL. We, in Revolut, use this guy. For us, Postgres solves 99 at least % of our data storage needs, and it works reasonably well. The added benefit is Postgres being a relational database with superpowers in terms of, for example, JSON processing. Can you reason about the consistency that Postgres has and offers? Yes, absolutely. Can you tell me what you expect the performance of the query if you have the text of the query to be? Absolutely, because it's using a relational engine, which means doing an explain is trivial and everybody or almost everybody can read about it on the internet. Many of you have done it during your studies, which means that knowledge is directly applicable. It doesn't get in the way. But it does not guarantee software being or not being modern, because right now that's not enough to decide. So then, is it the architecture? What kind of architecture should you use in order for your software to be called modern? Should you use Lambda? Should you define your own Gamma architecture? Should you maybe define something completely different? Again, you know the drift. Is using unit tests enough to call your software modern? Well, I think everybody agrees that usually people want to write more tests, or actually having written more tests sometime back ago in the past. But testing is necessary, but it doesn't guarantee that your software will remain this freshness, this modern feeling. Yeah? Okay, all good. And then, of course, there are the very energetic people who have the perfect solution for how to do the best software ever. I've recently heard some people say that specifically I have to use Kotlin, Kafka, and Kubernetes, and everything is going to be jolly. I also know some people who call those the 3K apocalypse. Just so that we're very clear, I am not going to say that any of those tools is right or wrong. It depends on the context. I'm not going to say that you should rewrite to or from. They are good tools. It's just, if somebody's approach to solving problems is you have to use those and then figure out how to fit the problem into those technologies, then you're approaching it backwards. We can actually go back to the question of frameworks. A couple years ago, well, actually it's more like maybe 12, 15 years ago, I heard a lot of people approach programming in Java in general by saying, hey, we have a new project. Great. We're going to use Spring and Hibernate. Yes, but you haven't heard what the project is going to do. That's a bit of a problematic or a backwards approach to choosing technologies. I do not recommend it. And then let's wait for the clicker to wake up. Yes. Bottom line of this phase of the presentation is adding new technology or adding new technology complexity to a problem, to a business problem that you do not fully understand because it's a new business problem that you're trying to do, trying to solve, is a recipe for, and here is somebody's option to scream something and get an invitation for example, for Spolina. Somebody said disaster. I would completely agree with you. What do you want? Mug? Invitation? A mug. Come and collect whenever it's convenient for you. Which means, bottom line, again, none of those components are necessary and essential to make a service modern. Or, why do we actually obsess? Why am I asking you what makes a service modern? Obviously, I'm doing that because I put this word in the presentation title, so yeah, kind of necessary. But is there anything wrong with legacy? What is legacy? What is the fact about working with legacy that we do not like, that we do not enjoy, that we hate, that so much that we switch to new companies that maybe have been founded 7 years ago because they have very well-tested software and actually are quite exciting to work with? Okay, enough of the pitch. The problem I would propose is something that I used to call, and I keep calling, calcification. Calcification in biology is a process that you know much better than I do, if you know it. But the definition says that it's basically a process in which, in the soft, fluffy tissue, calcium accumulates. In Polish, I think it would be zwapnienie, maybe. I don't speak Polish biology terms. And the tissue doesn't want to move anymore. And this is the big problem, the unpleasant part about working with what we usually refer to as legacy projects. I do not have a problem with projects which are legacy, as in old, dated. I have an issue with projects which are so tightly entangled, they use so much magic and every single side effect available to and known to humanity, that it's impossible to make a change without everything exploding everywhere for tens of weeks. This is insanity or a straight road into. So, let's go back in time. How do we go back in time? Obviously, this vehicle. Let's start with going back to year never, as in no calendars exist. We have, or do not, have the Big Bang, and we then realize that we actually have gone too far. So let's go to year 1997. In the year of 1997, there was a thing called EJBs. Who here has worked with EJBs in any of the versions? Me too, as well. We share the pains. According to Wikipedia, or as somebody told me, an overly simplistic and oversimplified history, it might be attributed partly to IBM. From what I know from people who have been doing Java in those days, it's not only IBM's fault, the actual picture is more complicated, but it's not really that relevant because we're not here to do archaeology of EJBs. It's just a thing that happened a long time ago, and that shaped how we do software, and that affects how we do software still. Then in year 1999, we've had the servlet specification 2.2, which you can interpret as web applications enter the Java platform. We can do web apps. Awesome. Then we have year 2001. We have this awesome movie with an awesome soundtrack, but we also get something else. We get EJBs 2.0. EJBs 2.0 are a direct response to EJBs 1.0, which are becoming faster because you don't have to do remote calls for something that is available to you on the same machine as in, yes, EJB once used to do an RMI call for every single call over EJB, even if you are calling from the web server and the the backend server, which happen to be the same process sometimes. Is it reasonable? I think it's an open question, very wide open question. And also they had something terrible, which was code generation using xdoclet. If you do not know what it is, good, keep it that way. If you remember what xdoclet is, I'm absolutely sorry for bringing back the horror memories of that. And then, year comes 2003. We get Spring 0.9. This came out as a direct response to EJBs, which were considered too complex and too untestable. And there was a bazillion of other problems with EJBs as well. And they came in while this book was being written, and I think most of you know the author. This is Rod Johnson, one of the authors of the Spring Framework, after all. And then, well, you can see a bit of a ping pong. And then, year 2005, we start observing something called AJAX. AJAX, as everybody knows, asynchronous, JavaScript, and JSON. And before you run in to correct me, is anybody actually using AJAX to send XML? Because everybody I know sends JSON. Then, year 2006, EJB 3.0, good, modern, faster, lighter, better. EJB 3.0 was done in the way it was and the shape it was done because EJBs before were considered too complex and because there was some competition from the Spring Framework. And then in year 2014, Spring Boot 1.0. Why did we get Spring Boot 1.0? Because Spring Framework became too complex. Can you see a pattern already? Yes, of course, you're an amazing audience. And then in year 2020, under one of the Confitura videos from, I don't remember which one, but there is a link, somebody said basically what is visible there, and my very loose, light translation of that is Java EE, so Java Enterprise Edition, had a small, well-thought API, 10 times smaller than Spring. If you remember the history, you can see that this is not exactly how it happened, but the impression somebody had in 2020 is that Java EE is the one with the small API, the light API, and Spring is the big bloated thing. I'm not going to say whether somebody is right or wrong there. Still, 2016, we get microprofile because Spring was considered too complex by some, which means we can come back to this question. What makes a service modern? What makes working with a service to be a very fresh, nice, pleasant experience? My theory is that the overall trend across frameworks and years, except when you're a highly paid consultant of a very dated technology like COBOL, is that we like to have more and more simplicity. We like to observe simplicity, for example, in the stack. How can you do a hello world in Java? Years ago, when servlets came out, you required a web descriptor, you required a web container, which probably might have been an application container, and there were containers and turtles all the way. Right now, or for the past few years, doing a hello world in web Java requires some of those options. This list is not exhaustive. There are more options out there, but what you can see there, it's basically a one-liner or maybe 2 or 3 liners. Definitely not the days in which a typical one-liner in Java is considered short if it's under 20 lines. So, why those frameworks? Just because, also because we use Spark Java and Revolut as our default for every single application, and Helidon is one of the possible successors, or Javelin. And before you ask me why do we want to switch frameworks, the answer is basically lying in those GitHub graphs. Those are the common activity of those frameworks. Helidon, plenty of activity over a few years. Spark Java, lots of activity, and then tiny small amounts. So basically this framework observes less changes, and having a framework that observes less changes obviously is a theory of, yes, this framework is considered complete, but in the web world we get new things and we get new dangers and risks which we need to be protected from by fixing and preventing security features, so security failures. So this is why we are looking at migrating out of Spark, which is kind of not very actively developed, into either Javelin or Helidon or maybe something else. And as I said, as at Revolut, we default to Spark Java, which means if you need to expose REST services, you're going to use Java and you're going to use Spark Java as the container. Is it limiting us? I hope not. If you ask me personally, one of the services I started to write recently in my spare time, I know, after you code at work, you write code as a hobby. It's a peculiar choice of hobbies. I like Helidon just because it feels simple, but I haven't tried all the options. And then let's come back to this question. How can we keep services being modern? My theory here is we want to prevent calcification. So how do you prevent it? let's look at the opposite. How does complexity happen? Complexity happens usually one commit at a time. I don't know too many people that have approached anything in the world with the attitude of let's build the most legacy system that we ever can. I've heard people who said, I don't care what we do, let's do whatever we want, whatever gets created. That's absolutely possible and very frequent. And there should be an asterisk. There used to be a Confitura, or it might have been a Java Sovia, in which somebody made a competition that you actually have to write the most legacy piece of software out there possible. Anybody remembers that? Nobody. So you have to believe me or not. But basically, this is not something, this is never the goal. It's something that just happens. So how can we prevent it from happening? We can use the very same litmus test that we apply to languages, or I propose that you apply to languages and apply to frameworks. So instead of saying we are going to use this framework and that framework, you can say I'm going to use this framework only if it gives me a lot of value, and it doesn't make it possible for legacy or calcification to happen. Again, 2 in the morning test. It's late, fun has been had. Is this framework, is this library helpful? Is it solving problems, or is it making you confused? If it's making you confused, if it's unessential, cut it out. And this test is creating 2 kinds of engineers. Those who have and those who have never fixed things late at night under a lot of stress. There is a tendency along the scarred engineers who have gone through the phases of those fixes to actually prefer much simpler, less magic, less esoteric, less exciting stacks, because yes, it's maybe boring, but I can see all the code that is being run, and I don't have to guess, and I don't have to remember, and I don't need to know about implicits, annotations, and all the magic that might happen in between. And if the code is tested, that's even better. So what do we do at Revolut? At Revolut, we apply the principle that we call no magic frameworks. This has nothing to do with Harry Potter. It's not only our invention, it's not something that we created, it's not something that we came up with. No magic frameworks are basically frameworks that have less complexity, less accidental, less non-essential complexity than the other frameworks that have been out there. So if you've worked with Drop Wizard, yes, it's less powerful than some others. If you've worked with Finagle, if you've worked with Javelin, Helidon, and so on, yes, they become more and more, well, simple. And that's okay, and that's normal. And this is because we have made a very conscious decision of getting rid and avoiding, like the plague, or more than the plague, of any unnecessary complexity in our software. How do we do it? Well, if I need to show you how an application starts, those are actual screenshots from Revolut applications. So if you want to start your own Revolut, well, just write this down and you're on a good start. Obviously, oversimplifying here. But if I ask any of you here in the audience, can you understand what happens here? Does it seem to make sense? You can nod with your heads, and I'm going to summarize this. I see one person yawning, basically. I think this is pretty straightforward. This is pretty explicit. There is nothing to guess around. Where is the database being migrated? Obviously over there. Easy to think and easy to debug. And then, what does it bring? This brings quality. Naturally, we write tests. We write a lot of tests. And the tests that we run come in 2 flavors. We call them unit tests, and we call them functional tests. Our division is everything that doesn't spin up the application, that just executes other pieces of Java code is going to be a unit test, and then a functional test is anything that is going to spin the application up using configuration and using, well, a fake database and lots of test containers in the way, and execute against the black box. Yes, test, there are different ways to call it, it's just what we use internally. Why do we look at those 2 things? Because we want to know the time we are building for. And what do I mean? What is the time range that we expect the applications to be up in production? How many years from now do we expect them to be around? So that if we need to come back to them, how many tests do we need? Because we want this stability to be out there. And there is a very nice picture, shamelessly copy-pasted from Martin Fowler's blog, and then link is in the bottom, which pictures this intuitively easy to understand and get this idea, this connection of how many tests for when. As you can see, quality versus delivery speed. We like being very early in the software lifecycle. Everybody, or almost everybody, likes working with a good new greenfield because nothing restricts you. It's very pleasant to do anything. You don't have to write tests. You don't have to worry about breaking tests because, yeah, there is nothing. So there is that. And then there is the point in which the application starts to live on for long enough that you don't want that to happen, which means actually having tests is adding more and more value. Maybe you've actually have had the pleasure of working with such an application. So there is this switch point, inflection point, I don't know what to call it. We, in Revolut, optimize for longevity, which means we have made a conscious decision to make technology decisions not from this point in the diagram when simple and unrestricted is not the perspective to have, but we want to think from the perspective of we've built those services. They are in production, they are supporting people, they are protecting their money, they are making whatever our customers want to do. What will make us more productive, more efficient when we are there and when things have been running and have been in production for a long time? So we say that it is inefficient to build software that immediately needs a rewrite, which means that has a lot of bugs. And what are some of the code patterns that help us get there? One is this typo-infused phrase, but basically that should be constructor-based injection. Somebody could say it's radical, but I would say it's really not, but that's a good discussion point. Another one is immutability, and that's something that you can approach in many, many places. By immutability, I mean using case data value classes as well as, and if you do that, that fits. If you use records, that fits. And what does the code look like? Well, the code looks like that. That's a random class from one of the random repositories. Nothing particularly important is here so that I mentioned the name of this, but if you look at an entity or an object like that, actually not an entity, what can you see? You can see IDs have their own types, which means it's impossible to compare a UUID-based wallet ID with a UUID-based maybe customer ID because they are represented by different Java types. Under the hood, they are UUIDs, of course, but at least the Java type system is going to prevent this category of errors. You can see that things are final, which means they do not change. And you can see one more thing. You can see this guy. This whole area in the constructor or in any of the builders that we do is going to check required, verify the assumptions that we have about the types, the parameters injected into this class or object or anything else, because we want to uphold invariance everywhere. So, for example, here, we want to make sure that the owner ID is required, and this check required is basically our syntax sugar so that the exception looks nice. And somebody could say, is that not redundant? And if somebody is fast, then they can actually scream it and get maybe an invite. No, you didn't fall for that. Is that not redundant? No, because those checks put in so many places, as the system grows, they will give you tiny amount of stability paste, stability dust that you sprinkle around the code, and that helps because you get compound interest, which means over time is actually worth more and more and more because you can make assumptions about what is the parameter. Is it null? No, because I verified it in every single place. But it's not null, that it actually follows whatever requirements I have there. And then, of course, Java 17, for those of you who haven't migrated or are not even the process or near the process of migrating, well, this is what you can do in terms of space savings, going from immutable classes to records. So yeah, of course I had to do that. But I know people out there have, for example, been saying or thinking, hey, but these guys could use Lombok. So any Lombok users in the room? Good. Can you tell me, is there a scenario in which this class can get into a bug or convert into a bug or trigger a bug? So somebody's saying Lombok might change something, how it's generating the code under the hood. Maybe, but this is not what I'm after. Okay, there is a hand raising there.
Let's say
threading issues. Maybe. Maybe there are threading issues being possible in there, but this is not what I'm about. You look at this and you see at data. So you expect probably it's a record. Probably something that basically is some data being put in one place. But also you will see there is a setter. Is there anything that prevents anybody from putting this as a key into a hash map or anything like that? No. But if you keep a reference to it and then you use the setter, then the only way for you to obtain this thing or to obtain the thing that it points to, if that's through a hash map, is to iterate, which means it's non-obvious, it's not explicit. Even to the Lombok users in the room, and I have nothing against Lombok or you in any way, it's just not explicit. And the fact that it's not explicit, it means if you're going to have to debug it, you will have to understand what happens because of those annotations, so that you know what happens, and maybe this is going to be a bug that needs to be fixed. Have you ever had to fix a bug with mutable keys in a hash map? Yes, I can see somebody smiling. It's not pleasant. It's just not a very thing. It's not the thing that you want to rely on or to actually be verifying all the time, because it requires a certain dose of insanity to distrust everything the computer is doing. So what about mutability? Option one, put it in the data store and use a lot of immutable code everywhere else. Option number two is going to be CQRS and event sourcing. We do both. I do not and will not have the time to tell you exactly how and why, but maybe there are future speakers from Revolut in this room who are going to make talks about it. Not pointing at anybody here right now, okay, I am. So, we use Postgres. As I said before, and as we all know it and love it, it has a very well understood consistency model, so no immediate inconsistency, no eventual consistency. It's just you know what's in there if the transactions have committed successfully, and predictable performance, which means if you need more performance out of queries, you can do explain, analyze, you can understand what Postgres tells you, add an index. Maybe that's not very exciting, but you know how to deal with that. And in a context of a company which enjoys a very constant growth of customer numbers, it is a thing, and it actually frees our brain cycles. Also, I said we like explicit, and we like explicit migration. So there are no DBAs, so people who will only touch the database and nobody else does it. No, the schema is together with the code. We use Flyway for this. So for, Flyway or Liquibase, for those of you who might not have heard, there are awesome frameworks which help you manage database migrations. We keep them in the source code or next to the source code, and as you have seen before, we have a migration that is going to apply that to the data store, so you can make assumptions and know what you're working with every single time. If you want to see how we got there, the code is right there explicitly. And of course, how do we test data stores? We use test containers. I've been told recently that there is a new Postgres in-memory testing option, but we haven't tried it, so I can't recommend it. And if somebody still hasn't figured out that Docker changed their licensing model, well, now you know about it. And we also use Juke. If you know Juke, you know what it does. If you don't know what Juke is a DSL for writing SQL queries. So you can write something like that, create.select from name of table, and then you do patch and da-da-da. What does it give us? Nobody has to write SQL by hand, which means we avoid certain kinds of errors. And also Juke is going to generate it for the dialect used at hand, which is just convenient. But the fact that it generates SQL rather than having, I don't know, JPA query language in between means we do not have to fiddle with logging level so that we can extract SQL out of the Hibernate or your other ORM, and it's explicit. If you need to add a field or add a filter or do something, you can, because it is explicit. If you are using Juke, you know it already. If you've never tried using Juke, I will say yes, absolutely use it, give it a try, because it's awesome. And then that brings us to one realization. Legacy happens. Just it eventually will, even to the best applications in the best of companies, and that's a fact. And software is going to be therefore well read, and people will try to sometimes pull their hair out more often than they actually get to modify it and make videos of pictures of people who actually speak about it. What can you do on the people level? You can define domains and areas of responsibility so that at least people know who owns what. And why is it important? Well, what does it give you? Well, if you have a number of maintainers or people who will be responsible, take ownership of an application or of a set of applications, then they can be the human, the soft tissue-based layers of stability, layers of quality defenders. That starts with an attitude called you build it, you run it. If I build an application, I do not give it to a deployment team and I do not give it to an execution production team. Me, as the team member of a specific team, I will run it, which means if I need to modify the infrastructure, I can. I'll just go and edit the YAMLs, commit them, re-trigger the CI thing and the CI job, and then my infrastructure will be redeployed, and deployed was the word I was after, and that will happen. If I need to change anything, I decide it's necessary, I do it. And also, if there are problems, I get to fix them. And how do we do it at Revolut? We also have something called Watchman. It's a process in which individuals, engineers, do triage and, they analyze and triage all of the inconsistencies and behaviors of applications during their workday. That's very important. So since the morning till the evening, not the other way around. And then they make tickets, and then they make bugs, and they assign them to teams that own specific applications. And why do we do it this way? Because first of all, it's those engineers who are going to be fixing issues for the applications they own. What makes a good bug report? As in, if you've done 1,000 or had to work with 1,000 of bug reports, you know what a good one looks like. But that also gives us visibility in what are the things and statuses and situations that other applications get into, and that makes this not somebody else's problems. There is no support team that's going to do it for us. No, it's us developers who are going to be directly impacted by the quality of the work that we do. And yeah, a reminder. People of the watch, so engineers who look for anomalies, engineers who triage and report bugs. Because those are the direct consequences of our actions, so we get to deal with the consequences, and that they actually feed back into the mental model of the applications that we are working with. Mental model, architecture, what about that part? Well, somebody could say, this is awesome. I am not going to say whether it is, I'm only going to say that I can see a lot of blue, and that's a picture stolen from one of the tweets. Somebody said that this is a microservice architecture of some organization. I can see a lot of dots. I would encourage people, rather than looking at fancy diagrams, is to believe that architecture is actually a bit more. I like to speak, and I agree with the definition of architecture as a shared understanding of how the software looks and what it does and how it gets there. So basically something that Martin Fowler has very well put in words before I even read it. So what does it look like when we are talking about architecture? Does this represent architecture? Nope, that is a list of an inventory which tells you what services do we have. Is this going to be cut into domains? Is this going to be enough to say we have an architecture? Well, no, because that's basically a service map, which is very helpful when you try to answer the question of where should a feature X, Y, Z go into, but not enough. Because you need a shared understanding, and you need to understand what affects you, and you want that feedback loop. So the question is, how do we get there? The question of architecture obviously is about documentation, because architecture as an understanding, it can be only in the code, but that's a bit inefficient in consuming this information when you want to deal with that. So the question is, how do we document this? How do we make this information radiated to other members of the company, so that if somebody wants to learn about service called, I don't know, banana, and I like using the word banana for this presentation for some reason, how do we get there? We do a process called technology design review. It's basically an RFC or a design review process with a bit of inspiration for an architecture decision log. An architecture decision log or an architecture decision record is basically a document which captures what decisions, under what circumstances, what else was also considered, and why did we decide to decide however we decided to make the decision. Great. So documents. Who makes these? Architects? No, because we have none. We have engineers, and if engineers need to design or define something, then they will do it. Who prepares documents for review? Who reviews them? The answer is exactly the same. Engineers. Why? Because we as engineers, we as the people who own and have to live with the consequences of service being developed and evolved in a certain way, have skin in the game. Something very natural, something trivial and natural for people who work with things. The anti-pattern or the opposition of this is the ivory tower architects, which we do not have. So people who have no connection with what they are making decisions about, but they will make the decisions about them very happily. And I know that C4 is basically the thing that everybody mentions today in Confitura, so I have to mention it as well. And if you need to have a way of documenting your architecture and your software, use the C4 model. Don't reinvent the wheel. Don't use UML. UML can die if you wanted to. And which tool do we use? Or which tool should you use if you have nothing? You do not need Enterprise Architect. You can use something called PlantUML. PlantUML is an awesome tool which allows you to work with something like this. As in, this is not PlantUML. This is another open source thing that allows you to store diagrams as text, and that will generate pictures for you. Why do we love text as software engineers? Because you can put it in Git next to the software. If somebody needs to update it, they don't need fancy Photoshop skills. They don't need to get a software team provisioning ticket solved, and so that they can actually get into a queue of waiting for an enterprise architect license. No, they can just do it and that gets done. Another thing is because that's text and because those diagramming tools are open source, you can put them in a CI loop and have those diagrams regenerated whenever somebody modifies them. And okay, we have diagrams, we have that. What about other services? Well, we use a model called internal open source, which means every engineer can read any other service that is in Revolut. As in, if you want to read the source of that, absolutely go and check it. If you want to make a pull request to the service I own, do it. I will have to review it as a maintainer, but everybody's welcome to collaborate because there is nothing secret, as in we're playing towards the same goal. And with that, who are the quality gates? I've already told you the answer. Those are the engineers who own the service. And then how do those services interact? Well, you can say that, well, we can put it in here, whether that's going to contribute to this architecture. Yes, maybe, no. And I will say no, it doesn't matter, because what is actually useful, what we found very useful, is define the interaction patterns that your services are going to have. And in our case, we have identified 3 major kinds of services. Not a lot. We have RPC, we have event-based, and we have batches. Any of the, or most of the interactions that we have in Revolut fall under one of those. The question is, how do we do them? What do we do in the context of RPCs? Because most of our software is in Java, because of most of our services is in Java, we have the benefit of actually doing something that's called clients. Clients as in client libraries to a service. If I do a service called Banana, I will also, if somebody else wants to use my service, make a Banana client so that you do not have to traverse and understand the schema of the REST interface that I have, because why would you? Instead of that, I'm going to give you a jar, or maybe a Python artifact, which will, under the hood, do whatever is necessary to talk to my service, but I, as the maintainer of this, can have it tested, can have it do the correct interactions, and you don't have to guess. Which, if you look at a couple hundred services, well, I would say we have roughly around 200 or 300 services in Revolut. That's the order of magnitude. That actually saves us a lot of time. Because if you need to use whatever, I don't know, Dumbo serves, and Dumbo is the name of a service that we have in Revolut, you're more than welcome to use Dumbo client in your application, and that gives you exactly the public API layer that it exposes. If you need it to do something more, make a PR, enhance the Dumbo client. The Dumbo service owners are going to merge it and, well, review it and then merge it if it's good, and then we're good. For events, we don't use Kafka just going to mention two things. Well, one thing called event store is basically a thin layer around Postgres that actually stores events for us. And somebody could now say, hey, you're almost out of time, or you're practically out of time. What about monitoring? What about Kubernetes, cloud native continuous delivery? Because I haven't mentioned any of those up until today. Well, up until now, actually. There is a realization that the fact that you are using Kubernetes is not going to give you an advantage over other organizations that might or might not use Kubernetes. In the domain in which we, as Revolut, operate, it makes no difference. Continuous delivery is an awesome pattern, it's an awesome practice, and we use it, of course. We also use Kubernetes, we use a lot of monitoring, but it's not going to give you an advantage. So we just try to solve it once and apply the patterns that we've established for solving it once well across all the applications. If somebody enhances that definition and makes it better, then all the services can get the benefits as well. We want the software to focus on solving business problems. And that brings us to a few points in which through which I'm going to skip very quickly because they are big conversation subjects on their own. For example, how do you capture business reality? There is an awesome technique called event storming, which is enough material to make a talk about, so I'm not going to do that, but maybe there are future Jack or present Jack speakers who are going to do that. And why is this reality a problem? Because software is usually a people problem. If you have protein-based processes, they do not scale. What I mean by they do not scale is if I have an application in a VM, in a container, even on-prem, I can put more machines. I can do it easily. If I want to add more support people, more developers into a process, I have to hire them, I have to train them, they have to be healthy, they have to be, well, available to work, and so on and so on. And that doesn't scale. We try to focus very much on not adding protein-based complexity into our software. So, TLDR, because we will have to come to an end, there is plenty of complexity in the businesses and in the business of whatever your companies are doing, and certainly the case for us. We, and you can, most likely, in many cases, optimize for the long term. So do it. Build quality and build resilience in, and software that is simple to understand and simple to reason about is going to be simple usually to scale and to change. And that brings us to something which has pictures, which means basically if you want inspiration and book recommendations, feel free to take a picture of this. If not, ask me for the slides and I will say enjoy the conference. Thank you. Time for questions. I think we have maybe 7 minutes before the next speaker starts. And thank you so much. Any questions? No. Problem solved.
I get a question.
Good. Shoot.
Isn't replacing ORM with Joke, isn't that just simplifying it rather than solving the problem of simplicity?
I don't know if I think I'm being recorded. So isn't replacing ORMs with Juke replacing a problem that we're solving? The problem that we wanted to address when using and choosing to use Juke was we want predictability in our persistence layer. Juke, by giving predictable, you can write tests about the SQL that gets generated. By giving predictable interactions with the data store, gives us exactly that. And that on top of scaling and growing company is very powerful. I would even say that for some trivial cases, you cannot hibernate or anything else in there, and that's actually doable and it will solve problems. But at the same time, the moment you do it, somebody's going to try to use Hibernate for writes. And if somebody's going to try to use Hibernate for writes and doesn't know Hibernate very well, you'll see a litany of save, refresh, reloads, whatever the entity model is, and you're nodding. This is exactly the problem we're trying to avoid. We're working with financial data. We need to be certain that something has been persisted, and if it has been persisted, it will not be lost. Because if we start losing information, it's a no, 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 no in our business. We cannot do that. So we use Juke because it gives us that. Do you want a mug or an invitation? Invitation. Awesome. Anybody else? Of course. Artur, go ahead.
Okay, so you mentioned that for all
Yes.
And don't they naturally form some kind of frameworks you expect to employ in all your applications?
So the question is for the recording. For things for repeatable things, we have identified. Yes, we have patterns of how to do them well. Do they form a framework of how we approach certain problems? Absolutely. So, for example, the answer to how do we do monitoring of any application in Revolut is we're going to do New Relic. Every single application is going to use New Relic in a specific way, and that means that if I need to investigate application X or application Y, I'm going to use the same mental patterns. If I have metrics around events, those are going to be the kinds of metrics that every application doing events needs, and that actually forms some code that usually will belong or be authored or owned by something like a platform team. And this is exactly what happens. We have some common infrastructure code, which is going to give you circuit breakers, which is going to give you timeouts, which is going to give you hooking up Docker for tests, glue code, so that nobody has to rewrite it over and over and over. So that goes into a common kind of library, and that saves us time.
And this means that you have to train new people from this unknown framework rather than to use something familiar to everybody in the industry.
Does it mean that we need to train people to our own libraries rather than using something that's familiar to everybody in the industry? I would love to be able to say that everybody in the industry knows something exactly the same way. This has not been our experience. Even if you look at frameworks like Spring or Hibernate, you will see completely different levels of skill and understanding. Some people will use them knowing their inside outs because they've debugged the annotation processors and they know what's happening inside, and they know very well what's in there. And if you could make an assumption that this is the piece of knowledge and understanding that we can rely on, we would be so happy to do it. But our experience with engineers has been that people usually don't have exactly the same super deep understanding of problems, and usually you don't need the framework magicians that many, because you need people who can do and solve business problems well, and capture the tests well, and convert business problems in the first place into code well. And that means that maybe their understanding of some frameworks is not amazing, which means if we take the complexity out of the technology domain and keep it under tabs, under, well, code that you can copy-paste basically from another Revolut application, but you can focus on what your business problem is, then that gives us some advantage. If you manage to find a way how to inject everybody with perfect knowledge of, for example, Java collections framework, just to start with, tell me, because I would love to know that. Would you like an invitation to the conference you organize? Is there anybody else that has any questions, comments?
So how do you deal with all these things you don't have because you don't use, for example, Twitter? Like, for example, transactional or some, I don't know. Something you can easily split business domain from something.
So the question is, how do we deal with the common elements that we could have trivially, with inverted air quotes, deal with by using a framework? We have, for transaction layers or transaction boundaries, we have a pattern. If you are interacting with a single database, you are going to execute, you're going to use an in-house library called Alpha, and it's a library, not a framework, that's going to do two things. Give you this boundary and do a begin transaction and commit at the very end. And it's also going to emit all of the events that you have created during that action and put them into event store. It does nothing else. That in turn means that this library, this tiny amount of code, is something that everybody is going to use. And if you need to deal with multiple databases, you're starting to talk about idempotent calls and so on. And those are the problems that usually have a business interpretation. So you have to approach them in some way, but this is not a technical problem at heart. It's a business problem because, I don't know, if you want to reorder the same card, which steps can you safely redo? If you redo the print order for a card, then you might get multiple printed cards. If you order multiple deliveries, you might get a single card attempted to be delivered multiple times, which again makes no sense. But sometimes it's actually safe to do. So idempotency and repeating calls and so on, it's up to the, well, it requires business specificity to answer. And I think I have to disconnect because other people are going to try to kick me out from here.